I want us to generalize equations. Several authors have defined equations, but simply I will define equation as a mathematical expression that has an equation sign, either algebraic, trigonometric, exponential equation, all forms of equations, all forms of expression, as long as it has an equation sign in between it, then it is referred to as equation. Now, we want to see a particular class of equation, which is the polynomial equation. This is the generalized form of a polynomial equation. And it is from this polynomial equation that we get all other forms of algebraic equations, such as linear, quadratic, cubic, and so on. In a nutshell, a polynomial equation of degree 1 is what we refer to as the linear equation. That implies that if our n is equal to 1 here, then we have p1 of x equals to a1 x raised to the power 1. And this definitely is linear. Why? Because the highest power here is equal to 1. And if our n is equals to 2, that implies that we have p2 of x equals to a2x squared plus a1 x plus our n equals to 2, that will be n minus n, which is 0, a0 x raised to the power 0, that will be 1, and we have this, which is the quadratic equation. If our n is equals to 3 from here, it follows that we have p3 of x now will be a3 x raised to the power 3 plus a2 x squared plus a1x plus a0. And this one is a cubic equation. What we are saying in essence here is, for a linear equation, I put the generalized form of it in terms of a, b, c, and so on, like that. So here the only solution we have is x equals to minus b over a, and that is why this is linear. It has one and only one solution. And for quadratic, what makes a quadratic equation is because the highest power of the variable x present in this expression is of order 2, is of degree 2, and therefore we have a quadratic equation. And after we solve this, we have x equals to minus b plus or minus root b squared minus 4ac over 2a. And by the time we had, then we have x equals to minus b plus root b squared minus 4ac over 2a. Here is one solution. Or when we subtract, now we have minus b minus root b squared minus 4ac all over 2a. These are the two solutions we have. This implies that when we have a cubic equation, we are going to get 3 different roots. If we have polynomial equation of degree 4, we have 4 different roots. I think that takes care of the general class of algebraic equation from the polynomial equation, from the polynomial expression that we have here. We can bring out our linear, quadratic, cubic, and so on, as long as it is an algebraic equation. Now, we want to look at the quadratic equation, because that is our major focus as far as this course is concerned. For a quadratic equation, we know that the standard form of a quadratic equation is I think I just remove it, so I'll call this quadratic equation now. quadratic equation. And the standard form now is ax squared plus bx plus c equals to 0. And here, our a must not be equals to 0. Why? Because immediately a is equals to 0, this is no longer a quadratic equation. This becomes a linear equation that has only one root. So, for quadratic equation, we have three major methods of solving a quadratic equation. Namely, the factorization method, the completing the square method that later leads to the quadratic formula, the one our student called almighty formula. And also, the final one is the graphical method. All of these we'll be treating shortly. For factorization method, for the factorization methods now, here we have two basic steps. First, we want to get, let me call it step 1. Step 1. We take the product of A times C. We need to get the value of AC. That will be step 1. Step 2 now will be, we get two factors of B, such that their sum will give us AC, such that their sum will give us B, and their product will give us AC. Let's assume that the two factors of B are alpha and beta, and it follows that alpha plus beta plus or minus beta must give us B, and alpha beta must produce AC. And after we have this, we now substitute the values of these factors, alpha and beta, back into the given equation in place of B. We can see that B here is the coefficient of variable X. Now, let's take an example. So for example, now we want to use this example to demonstrate what we have just mentioned earlier as the basic steps involved in factorization method. Using factorization method, we said we want to compute AC. A in this given example is equals to 1. And B, our B is equals to minus 3. A equals to 1 and B is minus 3. Definitely C is 2. When we compare this with the standard form of a quadratic equation, then we get the values of A, B, and C as this. Therefore, we want to get two factors such that when we add or subtract, we have minus 3. When we multiply, we have 2. And we have to take into cognizance the signs. They are very, very important. For the two factors now, if we take minus 1, for example, minus 2. Minus 1 minus 2 will definitely give us minus 3. Okay? If somebody somewhere go ahead and say 1 plus 2, that will also give us 3. But this is what we needed. So that one is very important. The sign is of essence here. And if we multiply minus 1 by minus 2, we also have 2. Don't forget, if I multiply 1 by 2, I will also have 2. But definitely, I must take this. Why? Because of this sign, minus there. So, after we have taken this step, what is the next? We substitute all of this back into the given example, which will be, therefore, the solution to this example now, 3x plus 2 equals to 0, implies that we now have x squared minus x minus 2x plus 2 equals to 0. The rest is just arithmetic now. From this now, we can see that this thing look alike. We factor x out of these two and we have x left here minus 1. If we factor 2 here, we have x minus 1, which will be equals to 0. we can see that x minus 1 is common. We also factor that x minus 1. We are left with x here. We are left with minus 2 here equals to 0. When we multiply two things, a times b equals to 0, it follows that either a or b is equals to 0. Therefore, if we have these two things multiplying each other and we have 0, definitely either x minus 1 is equals to 0 or x minus 2 is equals to 0. This implies that x is equals to 1 or x is equals to 2. So factorization is as simple as reciting 1, 2, 3. Maybe we will have some more further examples, but for now, let's quickly look at the remaining two methods. For now, we'll focus on the second method called the completing the square method. And we want to see how that one becomes the quadratic formula, the one popularly called the almighty formula by our students. So I will go back to the general form of a quadratic equation defined by this plus c equals to 0. And from here, what are the basic steps involved? I think I should write the method we want to describe now. Completing the square method. So for this, let me describe the steps involved as well. For completing the square, the first thing we want to achieve is make sure that the coefficient of x squared here becomes a unit. How do we do that? We just describe through by a, and we have x squared plus b over ax plus c over a equals to 0. I think that one is straightforward enough. Step 2 will definitely be, we take the average of the coefficient of x, which is now obviously b over a. I think I should write this thing straightforward. We can rewrite ax squared plus bx equals to minus c, because this one does not belong to this class at all. It's a constant, no variable there. They are separating. The fight has started already. I want to remove the constant away from it. We don't want to see this one here. It does not look like us. Now, from here, if we divide this through by a, then we have x squared plus b over ax equals to minus c over a. Now, we have achieved the first step. The second step now is to take care of this. We want to take the average of b over a. The average of b over a now is equals to b over 2a. And after that, we square the average. Then we add this to both sides of this equation. Let me call this one equation star. Therefore, equation star becomes x squared plus b over ax plus, I want to add this guy now, b over 2a all square equals to minus c over a plus b over 2a all square. The rest is just arithmetic. These are the basic steps involved in completing the square method. Now, let's break this down. From here, these two factors from the binomial expansion, we know that if we pick this guy and this guy, we add together and square both sides, we'll come back to this. Okay? Maybe in another slide, we take care of that. So from here, let me call that one equation star star, so that our work will be neat. From equation star star, x plus b over 2a all square will give us, I want to improve on this one a little bit, so that I have b square over 2a squared, which is now 4a squared. Because this one is minus, I want to throw it inside. Minus c over a. And from there I can take the LCM and I have 4a squared. 4a squared here, that will be 1 by b squared. I have b squared minus a here. I have 4a. 4a times c, that will be 4ac. 4ac. Okay? And now, from here, we now have x plus b over 2a all square equals to this. That takes us to a topic called the change of subject of formula. I am going to this. I am going to the variable x. So everything around variable x, they are my problem, they are my headache. I want to start taking care of them using paracetamol. What's the first paracetamol I will use? I want to deal with this square. And now, if I take the square root of both sides, this will disappear. So I have x plus b over 2a now equals to, we are using a square root. We always include the plus or minus sign. Why? Because we are getting two values. B squared minus 4ac over 4a squared. And this will give us plus or minus roots from our surds class. We know that if we have roots a over b, this is the same thing as root a over root b. That's from our surds class. We have described that one earlier. And now this will give us root 4a squared. Okay? And from here, we can reduce this one further. And we have x plus b over 2a now is equals to plus or minus root b squared minus 4ac over this guy here. Square root of 4, that one is 2. The square root of a squared, that one is a. And from here, I'm moving closer to the value of my x now. I want to get x. I want to remove this guy also from here. It's disturbing me. That's the second headache. Maybe we should use Panadol extra this time around. And now, if I remove this guy from here, because it's carrying a positive sign, when it gets there, it gets a negative sign. I think that one is a standard rule from our primary school that we know. B squared minus 4ac over 2a. And we can generalize this one using the LCM 2a. 2a here 1 by this, we have minus b. Plus or minus 2a here 1 by this, we have roots b squared minus 4ac, which is the almighty formula that we know. It is called the quadratic formula. Okay, we call it the general formula for solving quadratic equation. And from here, it follows that it's either our x is equals to minus b plus root b squared minus 4ac over 2a, or our x is minus b minus root b squared minus 4ac over 2a. And this is the completing the square, and we have been able to show how that one generates what we call the quadratic formula. And I think we can take at least an example to demonstrate this. By comparing this with our standard form of quadratic equation, which is this: a is 1, b is minus 3, and c is 2. Therefore, the formula, which is minus b plus or minus root b squared minus 4ac over 2a, by the time we substitute this, we have 3. Minus times minus now. Okay, let me take it. Plus or minus root minus 3 square minus 4 times 1 times, what is our C? 2 over 2 times 1. And this will give us 3 plus or minus roots. This will be 9. 9 minus 4 times 1 times 2, that's 8. All this over 2. And this will give us 3 plus root 1, which is 1, over 2, plus or minus. Therefore, we have been able to deal with the first part of this, which is the factorization methods and the completing the square, which leads to the quadratic formula. So this leads us to the discriminant. From the quadratic formula, we have x, where we have x equals to minus b plus or minus root b squared minus 4ac over 2a. From here, what we have inside the square root here, that is b squared minus 4ac, is called the discriminant. Let's denote this with letter D. So we say denoted by D. Therefore, if we have D, which is equals to b squared minus 4ac, we want to use this to discuss the nature of the roots of quadratic equations. 1. If this discriminant D is equals to 0, if our D is equals to 0, then we have 2 equal real roots. Okay? This implies that in this formula now, we will have x equals to minus b plus or minus root 0 over 2a, which implies that we have minus b over 2a twice. This will be our solution. And when we have d greater than 0, for d greater than 0, that is another type of root that we can have. Here we have, okay, let's substitute this into this. Let's call root d. We now have x equals to minus b plus or minus root d, okay, over 2a. But since we say whatever thing we get, let's say the value of root d, let's assume that root d will give us e. Therefore, the solution that we have now, x will be minus b plus or minus e over 2a. That is, if x is equals to minus this plus e, this one is a solution, or minus b minus e over 2a, another solution. So, which implies that we now have two different real roots. Or you say we have two distinct roots. Okay? The third form of this is when we have d. When we have d less than 0. When d is less than 0, then we say we have two unequal complex roots. Two unequal complex roots, or we say we have complex roots. That is, if we substitute, okay, for x equals to minus b plus or minus d. Okay, let's put it. as this over 2a. Your calculator will give us syntax error. It does not have definition for negative. That one calls for another topic which leads to a major aspect of mathematics called the complex number, and from there we have the complex analysis. Okay, that is that for the nature of roots of quadratic equation. In summary, we have three major roots that we can have. That is two distinct roots, two equal roots, and complex roots, or we say two distinct, since we have used distinct here, two distinct complex roots. And this one happens when our d is greater than 0. This one is when d is equal to 0, and this happens when d is less than 0. That's the three forms of roots that we can have, and this one describes the type of roots that we have for as regards the quadratic equation. Now, it is on this that we will now describe how the graphs of quadratic equation will look like. After the solution, the following are different types of graphs, shapes of graphs that we can have for quadratic equation. One, if we plot the x-axis versus the y-axis, and we have a curve like this, we know that this will be our y-axis standard and x-axis. This one, the type of root that we have here is what? Here, a is greater than 0, and this also implies that our d is greater than 0, which implies that we have two distinct roots. Why? Because this curve intercepts the x-axis at two different points, and those points will be the roots of this graph. That implies that if we are given any equation, any quadratic equation, and we have used the graph to demonstrate them, or to solve them rather, the 2 points where our curve intercepts the x-axis will be our two roots. Okay, which implies that we're going to have real roots here. And now, the other form that we can have is this. I want this to touch the x-axis. This is when our a is greater than 0 and our discriminant d is equals to 0. Okay, which implies that we have equal. This one will only touch the x-axis at a point. Okay, so that would be for when we have an equal root. The other form that we can have, the other type of graph that we can have from quadratic equation, if we have this and we have something like this, this is for complex roots. And if our a is less than 0, it follows that all these ones that we have had earlier, we can have something like this. Our curve will just face down now, okay, for y and x-axis. And for the equal roots, if a is also less than 0, for the equal roots we have something like this to touch a point. And that implies that the maximum point there will be a point on the x-axis, okay, and the minimum point is also a point at the x-axis. Okay, that's the difference. These are different types of graphs that we can plot as a solution of a quadratic equation.